we want to write the geometric series in sigma notation. So we've been given the series here, and the sigma notation looks like this. That little funny looking E is sigma, and we're going to have n equals a starting number, so we can start at any arbitrary number we want. Usually we start at 1 or 0, and the ending number, and that gives us a number of terms. The expression in this part here just represents the Tn formula. So in this case, let's work out the Tn formula first. We can see that the R value is equal to 1/2. So we start at 640, and we know that we're going to multiply by 1/2, and it's going to be n minus 1. So that's our Tn formula. So I'm going to just start writing that in. We're going to start at n equals 1. We have 640, 1/2 n minus 1, and that's all that's going to do is allow us to plug in the n and generate each term of that sequence. So what we have to also figure out is how many terms in this sequence. So if we end up at 10, we're going to end up with 1/2 is equal to n minus 1 is equal to 64, and we end up with, if we want to rewrite this in exponential form, we get 1/2 n minus 1, and this becomes 1 over 2 to the power 6. Okay, so what we can do is, once we equated the bases, we know that n minus 1 must equal to 6, okay, because 2 to the power 6 is equal to 64. So that's why I know that 1 over 64 is equal to 1/2 to the power 6. I can equate the exponents once I get to that point, and I calculate that n is equal to 7. So then I just write 7 at the top here. That's going to be my ending point. I'm going to start at 1. If I plug in 1, I get 640. If I plug in n equals 2, I get 320. All the way down to n is equal to 7, I get 10 as my calculation, and I can add up all those terms in that sigma notation. So this translates to 640 plus 320 plus ... plus 10. And that's my sigma notation for this particular series. Okay, I'm just going to move it over here so you can see it a little bit better, but there it is. Okay, so there's the sigma notation for that particular series.